Welcome to a quiet corner of the night, here with Dreamtime Science. Envision a cozy study, warmed by the amber flicker of candlelight, where the delicate rustle of flipping pages mingles with the hush of the world outside. You've arrived just in time for a peaceful voyage, one that carries you gently between waking and dreaming. If you find comfort in these stories, a gentle tap on the subscribe button would share your presence with us, and a comment telling us from where you listen would be a quiet gift. Now, ease yourself back into your resting place. Invite the cool softness of your blanket. Let your breath flow deep and calm. Together we will slowly unveil wonders meant to cradle your mind and ease your heart. When you are ready, we'll begin, slowly, softly, simply. Tonight, as we drift softly through the velvet night, we'll glide very slowly, very gently into a curious question. Might distant aliens, far beyond our stars, be watching the flickering glow of our old TV shows? From a safe, pillow-soft distance, we'll explore the quiet mysteries of signals wandering through space, inviting wonder without haste or noise. Should these dreamy explorations accompany your journey to sleep, a gentle like or subscription would be deeply appreciated. What questions about our universe keep you wonderfully curious? Take this moment to settle in, wrap yourself in comfort, release the day's weight from your shoulders, and let your breath become as gentle as starlight. Somewhere high above you, the night sky stretches out, a deep ocean scattered with diamond pinpricks, a timeless canopy that has received and reflected the dreams of every generation. On a quiet night, as you lie in bed and let your thoughts drift upward, you may wonder what it is that truly connects us to those distant, silent stars. Perhaps you imagine the vastness as an impassable gulf, a void so immense that it swallows every whisper and every longing. But science, with its gentle, persistent probing, has revealed a different truth. The void is not silent. It hums with a symphony of invisible messages, a chorus of signals born from the inventions and imaginings of humankind. These are the radio waves, our accidental ambassadors to the cosmos. To truly sense the wonder of these waves, you must first invite your mind to slow and attune itself to the strange, invisible dance of electromagnetic energy. In the world of physics, there exists a great family of vibrations, a spectrum of waves that travel through the fabric of space at the ultimate speed, the speed of light. Some of these waves our eyes can see, the colors that paint the day, the glow of a candle, the shimmer of a rainbow. But beyond the red, beyond the violet, and nestled in the long, rolling undulations of the spectrum lie the radio waves. They are light, but of a frequency too gentle for human sight. Instead, they pass through walls, bend around mountains, and slip through the air with ease, carrying their secrets across continents and, yes, into the star-strewn night. Radio waves owe their existence to the restless motion of electric charges, electrons shuttling and swirling inside wires, driven by the pulse of oscillators and the ingenuity of engineers. When an alternating current surges along an antenna, It pushes electric and magnetic fields outward, detaching them from their source, like ripples from a pebble dropped in a pond. These ripples, these electromagnetic waves, spread in all directions, diminishing in strength but never truly vanishing. They are tireless travelers, crossing the boundaries between earth and sky, between our world and the infinity beyond. It is a peculiar fact that every moment you are bathed in a haze of radio energy, so faint that your body does not notice, so omnipresent that it is all but inescapable. From the quiet static between radio stations to the rhythmic beeps of navigation satellites and the coded bursts of distant transmitters, the air is alive with invisible motion. In the earliest days of wireless communication, humanity learned to harness these waves to send simple messages, dots and dashes, voices crackling with static, melodies born on the ether. The first broadcast voices, the earliest Morse signals, were never meant for the heavens. Yet unbidden, they leapt from their antennas and began a journey that, in theory, could continue forever. Here, the story takes on a certain poetry. As you drift in your thoughts, imagine a sphere of expanding radio light growing outward from the Earth at the speed of 300,000 kilometers per second. Each year, the oldest broadcasts push another light year into the cosmic darkness, tracing the history of our civilization as a sequence of ever-widening shells. Somewhere, 100 light years from home, a faint ghost of a jazz melody, perhaps from a 1920s Parisian cafe, is sliding past a quiet star. The first frantic news bulletins of the Second World War are now far beyond the nearest stars. The crackling voice of Neil Armstrong stepping onto the moon has swept out past the solar system and continues its pilgrimage among the icy moons of Jupiter and Saturn. Is there anyone out there to receive these echoes? This question, so simple and so profound, has captured the imagination of storytellers and scientists alike. In the silent reaches between the stars, what would it mean for another mind, alien, ancient, or just astonishingly different, to tune in to our cosmic broadcasts? Popular culture has woven 1,000 tales from this thread of possibility. In the film Contact, based on the novel by Carl Sagan, humanity's first undeniable proof of extraterrestrial intelligence arrives not as a spaceship or a message in mathematics, but as the reflection of our own radio waves, the first televised broadcast of the Olympic Games in 1936, rebroadcast to us by alien hands as a kind of cosmic greeting. The story is both a celebration of scientific wonder and a meditation on the strange way we reach for the unknown, sending our stories and our noise into the void, never knowing who, if anyone, might be listening. Radio waves, in their quiet persistence, are the most democratic of travelers. They are not limited by language or by the boundaries of nations. They are not even impeded in the long run by the boundaries of our own solar system. Once sent, they move outward inexorably, traversing the interstellar medium, a thin, cold soup of gas and dust that fills the spaces between stars. For decades, scientists have wondered just how far a human broadcast might travel before it is lost in the cosmic background, overwhelmed by the hiss and crackle of natural radio noise. In theory, with a sensitive enough receiver and enough patience, even the faintest signal could be plucked from the depths, decoded and understood. The practical reality is both humbling and awe-inspiring. The signals we send are strong nearby, but they weaken rapidly with distance, spreading their energy thin as they flow outward in all directions. By the time a terrestrial television broadcast has traveled just a few light years, its power has dwindled to a whisper, easily lost amid the roar of cosmic static, the background hiss from the birth of the universe itself. Yet the possibility remains. In the vast silence between the stars, our signals are there, tiny yet indelible, written into the fabric of space, waiting for someone or something with ears keen enough to hear. Science fiction has long feasted on this tantalizing possibility. The communicators of Star Trek, the vast subspace arrays and interstellar relays, all owe their imaginative spark to the simple, real-world radio wave. In the imagined worlds of tomorrow, humanity converses with distant planets as easily as with neighbors across a fence. The notion that a message once sent cannot be unsent, that every broadcast leaves a permanent mark on the universe, has haunted the dreams of both optimists and pessimists. What, after all, do our broadcasts say about us? What might an extraterrestrial intelligence learn of humanity from our music, our news, our laughter and our pain, all encoded in the vibrations of electromagnetic energy? Yet for all its poetic allure, the science of radio wave propagation is grounded in the elegant mathematics of Maxwell's equations, the set of laws that describe how electric and magnetic fields interact and give birth to electromagnetic waves. These equations, formulated in the 19th century, predicted the very existence of radio waves before they were ever detected. James Clerk Maxwell's insight was profound. Light itself is an electromagnetic wave, and so too are the radio waves that would one day link continents and perhaps civilizations. As radio waves leave the shelter of our planet, they must traverse the Earth's atmosphere, a complex, layered veil that reflects, absorbs, and sometimes distorts the signals we send. The ionosphere, a shell of charged particles high above the surface, acts as both a mirror and a window. For certain frequencies, it bounces radio waves back to Earth, allowing signals to travel beyond the horizon. Shortwave radio, beloved by amateur operators and clandestine broadcasters alike, can reach listeners half a world away thanks to this atmospheric ricochet. But higher frequency waves, FM radio, television, and the signals of deep space telescopes pierce straight through, escaping into the blackness beyond. Once in space, radio waves encounter almost nothing to impede them. The vacuum is not truly empty, but it is empty enough that for the purposes of electromagnetic waves, it is a near-perfect highway. There is no friction, no resistance, no decay, save for the gradual spreading of the wavefront. The only obstacles are the rare encounters with interstellar gas or dust, which can scatter or absorb the waves, but only feebly. In this way, every powerful radio transmission ever sent from Earth is, in principle, still racing outward, a series of expanding spheres, each centered on the moment of its origin. There is a poignant humility in this idea. For most of human history, our stories were passed from parent to child, from elder to apprentice, fading with each retelling, each generation. The invention of writing granted a kind of permanence, but even ink fades, parchment crumbles, and stone erodes. Radio and television, in their own way, grant us a new kind of immortality, not for individuals, but for the culture as a whole. Each broadcast is a time capsule, flung into the interstellar dark, a record of our hopes, our fears, our follies, and our triumphs. The science fiction writers, ever attuned to the poetic resonances of technology, have played with this idea in myriad ways. In the universe of Star Trek, entire civilizations are shaped by the chance reception of Earth's radio and television broadcasts, with cultures on distant worlds mimicking the gangsters of 1920s Chicago or the vaudeville routines of early Hollywood. In Contact, the echo of our own message, returned to us from the stars, becomes a symbol of both our loneliness and our longing for connection. Even in stories of menace and caution, where alien invaders are drawn to Earth by our unguarded transmissions, there is the underlying recognition that we are inescapably a broadcasting species. To be human is to send signals, to reach out even when the sender cannot know if there is a receiver. But for all the imagination and speculation, the reality is, in some ways, more wondrous still. The universe, as we now know, is teeming with its own radio symphony. Pulsars, rapidly rotating neutron stars, emit beams of radio energy as regular as the ticking of a cosmic clock. The planet Jupiter, with its mighty magnetic field, produces radio storms that would deafen the ears of any alien listening nearby. The relic glow of the Big Bang, the cosmic microwave background, suffuses all of space with a faint radio hiss, a lingering echo of the universe's fiery birth. Into this chorus, humanity has added its own melody, the pulse of radar, the chatter of satellites, the steady hum of broadcast towers. Our signals are faint, but they are distinct, an artificial pattern against a natural backdrop, a sign that somewhere, on a small blue planet, there exists a species that has learned to harness the invisible threads of the cosmos and weave them into stories. If you close your eyes and let your imagination wander, you might picture a distant world orbiting a far-off sun, where some alien intelligence has constructed an immense ear, a radio telescope of unfathomable sensitivity, tuned to the faintest whispers from the stars. One day, amid the cosmic static, they detect a pattern, a rising and falling melody, a fragment of human speech, the laughter of children, the crescendo of a symphony. For them it is a puzzle, a sign that they are not alone. For us it is the ultimate act of hope, a message sent blindly into the dark, trusting that the universe is listening. Yet in our own time, the journey is only beginning. Each night, as the world sleeps and the sky turns overhead, new signals leap from the surface and join the expanding sphere of human radio light. The story of these waves, of their travels and their encounters, is still being written, and as we lie beneath the stars, pondering the silence and the music of the void, we are left to wonder what new harmonies, what strange new signals might someday answer our own. Somewhere between the slow turning of stars and the aching hush of interstellar space, a message sets forth from a world. The message, a pulse of radio waves, finely modulated and deliberate, leaves its home on a tide of hope, propelled by the fervent desire for connection. It could be a tightly coded binary sequence, a simple hello encrypted in mathematics, or a sweep of prime numbers meant to bridge the gulf of language. Perhaps it's the faint tremble of a carrier wave that once hummed from the great radio telescopes at Arecibo or Goldstone, or the gentle, stately broadcast of the Voyager golden record, whispering music and greetings in dozens of tongues. But as this message journeys outward, away from its cradle, it begins to unravel, not in meaning, but in strength. The universe is vast beyond imagining, and the fabric through which the message must travel is by no means empty. Here, the simple act of reaching out becomes a story in itself, a saga of endurance and attrition, of signals battered and eroded by the unyielding realities of physics. If the cosmos is an ocean, then every message is a fragile bottle, its contents vulnerable to the tides and tempests that sweep between stars. The first and most implacable of these realities is the inverse square law, a stern and ancient rule that governs the journey of all things that radiate outward: light, sound, gravitational whispers, and of course radio waves. Imagine for a moment a small campfire in the wilderness, its flickering warmth inviting. Step away and the glow fades. Double your distance and the fire's light dims, not just by half, but to a quarter of its former glory. The law is merciless in its certainty. The intensity of any point source radiation decreases in proportion to the square of the distance from its source. Let us follow the message as it leaves the safety of its world, riding the ether at the speed of light. At 1 light-year's remove, the transmission's energy is spread thinly across the surface of an imaginary sphere. A bubble now vast, its surface area calculated as 4 times pi times the radius squared. Every time the radius doubles, the same energy must stretch itself over 4 times as much area. At 10 light years, the signal is a ghost of its former self. At 100, it is so faint that it teeters on the edge of detectability. The message, so vibrant at its birth, becomes a mere whisper, indistinguishable from the cosmic background to all but the most sensitive of ears. This is the first great challenge, the tyranny of dilution. No matter how powerful the original transmitter, no matter how finely tuned the machinery, the signal withers with distance, its energy endlessly dispersed. To listen for such a message is to strain against the silence, to gather faint photons and tease out patterns from the hush. The universe, for all its scale, is not kind to those who would speak across its breadth. Yet there are other hazards that beset the traveller. The interstellar medium, that tenuous mixture of gas and dust that drifts between the stars, is not entirely passive. It is not a perfect vacuum, but a thin soup of hydrogen atoms, electrons, and cosmic grains, each capable of interacting with the passing signal. As the radio wave courses through this medium, it suffers scattering and absorption. At some frequencies, clouds of neutral hydrogen are opaque, swallowing the wave entirely. At others, the signal is refracted, bent, or delayed. These effects are subtle, almost gentle, but over light years they accumulate, smudging the crispness of the original message, diffusing its edges like ink bleeding through ancient parchment. Cosmic rays, too, dart and dance through this expanse, charged particles accelerated by supernovae and stellar winds. When they encounter the delicate electronics of a receiver, or even the molecules of a message-carrying wave, they can induce noise and static, further obscuring what little remains. On Earth, our own atmosphere adds its signature. Ionospheric turbulence, lightning, and the endless chatter of terrestrial technology compete for attention, crowding the cosmic signal into ever narrower bands. Consider for a moment the task of the listener. Somewhere, perhaps on a world orbiting a distant sun, a civilization erects its own great dish, tuning its receivers to the heavens with exquisite care. The astronomers wait in darkness, ears pressed to the void, their equipment chilled to within fractions of a degree above absolute zero to reduce the hiss of thermal noise. They must sift through torrents of static, parsing out the faintest hints of artificiality, a regular pulse, a sudden spike at an unlikely frequency, a pattern that cannot be explained by physics alone. The challenge is not just in the receiving, but in the very crafting of the message. What frequency should one choose? Too low, and the signal is swallowed by galactic background noise. Too high, and it is absorbed by interstellar dust. There is a quiet zone in the radio spectrum, a band between the emissions of neutral hydrogen and hydroxyl radicals, where noise is least and clarity greatest. It is here, in this narrow window, that our most hopeful messages are often sent, guided by the logic that any other searchers would be drawn to the same cosmic silence. Even so, the act of distinguishing signal from noise is a science and an art. Natural astrophysical phenomena are prodigious broadcasters. Pulsars spin and flicker with clockwork regularity, quasars scream across the electromagnetic spectrum, and distant thunderstorms on alien worlds may add their own static. The universe is alive with sound, but so much of it is accidental, the byproduct of natural forces. To find the artificial amidst this chaos is to seek a needle not just in one haystack, but in a field of haystacks, each piled higher than mountains. The signal if it is to endure, must be crafted to resist these indignities. Modulation schemes are chosen for their resilience. Binary codes, frequency shifts, or even prime number sequences, which are unlikely to arise by chance. Redundancy is built in, the message repeated and interleaved, so that even if fragments are lost, the whole may be reconstructed. In recent years, scientists have even considered encoding messages as bursts of energy at mathematically significant intervals, or as images composed of pixels arranged in prime-numbered grids. Yet for all this cleverness, the signal remains heartbreakingly fragile. The further it travels, the more it is battered by the odds. The universe is not a friendly carrier. Its distances are so immense, its hazards so subtle yet persistent, that the very idea of interstellar conversation begins to seem quixotic, an act of faith as much as of science. And still we persist. Our great radio telescopes, like Arecibo before its fall, or the square-kilometre array, now rising in the deserts of South Africa and Australia, reach outward with ever greater sensitivity. We construct vast arrays of antennas, linking them across continents to increase our resolving power, combining their signals in a dance of electronics and mathematics. The dream is simple, elemental, to hear a whisper from the dark, to know that we are not alone. But even as we listen, we must consider the possibility that others may be reaching out as well, their messages subject to the same erosions and indignities. Perhaps their signals, too, are flickering and faint, lost amidst the roar of cosmic background radiation, or scattered by dust clouds 1,000 light-years thick. If communication is possible at all, it must be both resilient and patient, measured not in minutes or hours, but in decades and centuries. There is, inevitably, a poignancy in this effort. The messages we send may take centuries to arrive. The answers, if they come, may reach us long after their senders and their receivers alike have turned to dust. It is a dialogue conducted in deep time, a conversation that spans the ages. The very act of sending, a binary pulse, a mathematical sequence, a snippet of music, becomes an offering to the future, a testament to hope in the face of silence. Consider now the notion of channel capacity, the theoretical limit to how much information can be sent through a noisy channel. This, too, is dictated by the laws of information theory, as discovered by Claude Shannon in the middle of the 20th century. For every channel, there is a maximum rate at which data can be reliably transmitted, given the power of the signal and the level of noise. Increase your power, and you may send more. But the inverse square law, relentless as gravity, means that power is always a fleeting advantage, quickly eroded by distance. Sharpen your receivers, and you can squeeze more from the static, but randomness will always claim its share. We are thus compelled to simplicity. Our messages must be clear, redundant, and modest in their demands. In the most optimistic scenarios, a message sent from Earth to a nearby star might carry only a handful of bits per second, or less, enough perhaps to encode a greeting, a snippet of mathematics, a simple melody. Anything more is lost to entropy and the grinding attrition of space. Yet for all the difficulties we find ways to persevere. Pulses are repeated, their patterns stretched across years. Data is compressed and encoded, maximizing the chance that something intelligible will survive. We send not just one message, but 1,000, across frequencies and epochs, a chorus of voices raised in the hope that one will be heard. And what of the time it takes? At the speed of light, even our closest stellar neighbors are years away. Proxima Centauri, the nearest star beyond our sun, lies over 4 light-years distant. A message sent today will not arrive until the next presidential election has come and gone, until children born this year are in school. The return message, if it is sent at once, will not be heard for nearly a decade. Across greater spans, the delay stretches into centuries and millennia. To converse across the stars is to write letters for descendants unborn, to trust in the endurance of language and civilization. All of this, the inverse square law, the scattering and absorption, the tyranny of noise, means that every message in a cosmic bottle is precious and precarious. Each is cast upon the tides of interstellar space with no guarantee of landfall, no certainty of reply. And yet, scattered across the great silence, we continue to send them, and to listen and to hope. Somewhere, perhaps, another civilization faces the same challenges, their own messages battered by distance and dust, their own receivers straining to catch a fleeting whisper from the dark. Even now, as we sharpen our instruments and refine our codes, the cosmos remains indifferent. Its silence is not an answer, but a condition, a canvas upon which we project our longing and our ingenuity. The challenge is not only technical, but existential. To persevere in the face of uncertainty, to create meaning in the act of reaching out, even when the odds are long and the prospects remote. The night sky, for all its stillness, is alive with possibilities. Each star is a potential correspondent, each nebula a veil behind which secrets may hide. The messages we send, and those we strain to hear, are more than mere data. They are acts of faith, expressions of curiosity and kinship across the void. And as we refine our technology, as we probe deeper into the mysteries of the interstellar medium, we find new ways to adapt, to amplify, to persist. For the story of cosmic communication is not only about the messages themselves, but about the ways in which we rise to meet the challenges of distance and degradation. Each advance in technology, each clever encoding, each new array of antennas is a testament to our determination to bridge the unbridgeable, to find signal in the noise, to connect with minds as yet unknown. Out there, between the stars, the journey of the message continues, battered, diminished, but not defeated. It carries with it the hopes and dreams of its makers, the sum of their knowledge, the cadence of their languages, and the patterns of their thoughts. And always there is the possibility that somewhere a receiver waits in the darkness, poised to catch a whisper from across the ages, a message in a cosmic bottle, bobbing on seas uncharted, awaiting discovery. And so the night deepens, and the silence grows profound. But in that silence there is movement, faint, persistent, and full of promise. The next step in our journey will bring us deeper into the subtle art of listening, to the patient labor of those who scan the heavens for a sign, and the ingenious methods by which we strive to lift signal from noise, to conjure meaning from the hush of space. For the story of cosmic communication is far from finished. The greatest challenges and the greatest hopes yet await. To listen in on the universe is to become a quiet observer, a patient eavesdropper at the edge of a cosmic conversation that began long before any human ear could hope to hear. Through the black velvet of night, ripples of radio energy, messages not meant for us, stream silently across the gulfs of space. In their patterns and pauses, they carry secrets from times and places we may never visit. Yet, with clever instruments and persistent curiosity, humanity has learned to catch these whispers, decode their stories, and even send a few signals of our own, hoping for a reply. The earliest attempts to listen to radio waves from the cosmos were almost accidental, born from terrestrial inventions and the growing power of human curiosity. In the 1930s, when the world was still enthralled by the crackle and hum of terrestrial radio, an engineer named Karl Jansky set out on a practical, earthbound mission. He worked for Bell Telephone Laboratories, tasked with identifying sources of static that might interfere with transatlantic radio communications. To this end, he built a peculiar contraption, a rotating antenna mounted on a Ford Model T chassis for maneuverability, which he called his merry-go-round. Jansky's antenna was a primitive beast by today's standards, a skeleton of wires and wood, turning ponderously to sample the sky. Yet as he recorded the hiss and pop of atmospheric interference, he noticed a persistent background static, one that waxed and waned on a cycle not matched to the sun or to any human activity. The signal peaked every 23 hours and 56 minutes, the period of a sidereal day, the time it takes for the Earth to complete one rotation relative to the distant stars, not the sun. This clue, subtle but profound, told Jansky he was listening to something far grander than thunderstorms or faulty circuits. He was hearing the Milky Way itself, radiating in the radio band, the galaxy's heart beating out its presence in the language of electromagnetic waves. Word of Jansky's discovery drifted through the scientific community like the static he had measured, sparking the imaginations of a handful of physicists and engineers. One of those was Grote Reber, an amateur radio operator from Wheaton, Illinois. Lacking institutional support, but brimming with determination, Reber set about building the world's first purpose-built radio telescope in his backyard. His was a dish 9 meters across, fashioned from sheet metal and wood, and pointed skyward like a great steel ear. Reber swept the heavens, mapping the radio brightness of the sky, confirming Jansky's detection, and revealing the structure of the galaxy in a new kind of light. This simple act of catching, amplifying, and recording radio waves from space was the seed from which a new science grew. Radio astronomy, as it came to be called, opened a vast, previously invisible universe, where optical telescopes could peer only at the relatively nearby, unclouded by dust, radio telescopes could see through cosmic fog, glimpsing the hearts of galaxies and the birthplaces of stars. The universe, it turned out, was not silent at all. In those early decades, radio astronomers were inventors as much as observers, their tools evolving in response to the signals they sought. The parabolic dish, like Reber's backyard experiment, proved to be a simple, powerful design. It gathered faint radio waves, reflecting them to a single focus where a sensitive receiver could detect their feeble energy. As the need for greater sensitivity grew, so too did the size of these dishes. The 76-metre Lovell telescope at Jodrell Bank rose in the English countryside, its vast bowl capable of collecting whispers from across the cosmos. The 100-metre Greenbank telescope in West Virginia and the 305-metre dish at Arecibo in Puerto Rico pushed the limits further, each a monument to the dream of hearing farther, fainter voices. But not all radio telescopes reached for size alone. Some, like the Very Large Array, VLA, in the high desert of New Mexico, multiplied their power by working together. Here, 27 dishes, each 25 meters in diameter, are arranged in a Y-shaped pattern, their signals combined through a process known as interferometry. By carefully timing the arrival of radio waves at each dish, astronomers can reconstruct images with a resolution far beyond what any single dish could achieve. The VLA can, in effect, see as sharply as a telescope the size of its entire array, many kilometers across. This technique has blossomed into global collaborations. The Very Long Baseline Array, VLBA, links radio telescopes across continents, synthesizing an Earth-sized eye capable of resolving details as fine as a milliarc second, equivalent to distinguishing a golf ball on the moon from Earth. The sophistication of these instruments is matched by the ingenuity of their receivers. Radio waves from space are astonishingly faint, often swamped by the cacophony of human-made interference, the static of electronics, the buzz of power lines, the ever-present chatter of satellites and radar. To pick out the cosmos from the noise, astronomers cool their detectors to near absolute zero, reducing thermal noise to a whisper. They shield their observatories from terrestrial signals, situating them in radio-quiet valleys or even on the far side of the moon, in imagination, if not yet in practice. The receivers themselves are marvels of engineering, amplifying the minuscule energy of a photon by factors of 1 billion, converting the analog dance of radio waves into digital data streams that can be sifted, sorted, and reconstructed into maps of the universe. With these tools, the discoveries have flowed in a torrent. Pulsars, rapidly spinning neutron stars, sending out lighthouse beams of radio energy, were found by Jocelyn Bell Burnell and her colleagues in the late 1960s, their signals so regular that for a moment they were dubbed LGM-1, Little Green Men. radio telescopes revealed the structure of the Milky Way's spiral arms, mapped the afterglow of the Big Bang in the cosmic microwave background, and traced the jets and lobes of radio galaxies powered by supermassive black holes at their cores. Each new frequency band, each leap in sensitivity, peeled back another layer of cosmic mystery, giving voice to phenomena invisible to optical eyes. The spectrum of radio waves is vast, running from wavelengths of a few millimeters to many meters, and each region holds its own secrets. At 21 centimeters, the so-called hydrogen line, the universe whispers in the language of its most abundant atom. This faint emission arises when the electron in a hydrogen atom flips its spin relative to the proton, emitting a photon at a precise frequency, 1420 megahertz. It is a faint, persistent hum, easily blocked by the interference of radio transmitters and cell phones. Yet it is the key to mapping the cold, diffuse gas that threads galaxies together. By tuning their instruments to this frequency, astronomers have charted the Milky Way and other galaxies, tracking the dance of gas clouds as they wheel around invisible centers of mass. Other frequencies tell different stories. Molecules in interstellar clouds spinning and vibrating emit at characteristic radio wavelengths. By detecting these spectral fingerprints, astronomers identify complex organic molecules floating between the stars, the ingredients of life scattered on cosmic winds. Quasars, the blazing hearts of young galaxies, beam out powerful radio jets that pierce the intergalactic medium, tracing the growth of galaxies across cosmic time. Yet for all the wonders revealed, there remains a persistent, almost philosophical longing, the hope that somewhere in the static we might catch a signal not of natural origin, but of intelligence, an intentional whisper from another mind. This longing has given birth to one of the most ambitious and romantic projects in the history of science, the search for extraterrestrial intelligence, or SETI. The roots of SETI are tangled with the history of radio astronomy itself. As soon as it became clear that the cosmos was filled with radio noise, the question arose, could some of it be a message? In 1960, Frank Drake conducted the first systematic search, tuning a radio dish at Green Bank to two nearby stars, Epsilon Eridani and Tau Ceti, listening for narrow-band signals that could betray the presence of alien transmitters. The experiment known as Project Ozma was modest in scope, a few weeks of listening, a handful of frequencies, but it set the template for decades to come. SETI has expanded since those early days, harnessing ever larger arrays and more sophisticated computers. The basic premise remains elegant in its simplicity. Natural radio sources tend to be broad and noisy, their emissions spread out across wide swaths of the spectrum. An artificial transmitter, by contrast, might choose a pure, narrow frequency, a beacon that stands out against the background like a lighthouse on a stormy shore. By scanning the sky, frequency by frequency, SETI experiments seek these beacons, filtering out terrestrial interference, cataloguing the hiss and pop of known sources, and flagging anything that cannot be easily explained. The search is daunting, the radio spectrum is vast, and the universe is large. Even with the most sensitive instruments, we are listening with a thimble to an ocean of possibility, yet the tools grow ever more capable. The Allen Telescope Array, a field of dozens of small dishes in Northern California, was designed specifically for SETI, able to scan wide swaths of sky and frequency at once. Digital backends, clusters of computers, sift through the incoming data at rates unthinkable a generation ago, flagging potential signals for closer inspection. SETI has also become a truly public endeavor. The SETI at Home project, launched in 1999, harnessed the idle processing power of millions of personal computers around the world, each chipping away at the cosmic haystack, searching for the needle of a signal. For a while, ordinary people could become eavesdroppers, their machines joining the great listening post of Earth. Yet the cosmos has remained so far resolutely silent. The signals detected are the music of nature, not the language of minds. Fast radio bursts, brief, powerful explosions of radio energy have tantalized astronomers, but their origins appear to be natural, not engineered. The wow signal, a strong narrowband burst detected in 1977, has never been repeated, remaining an enigmatic blip in the cosmic hum. Still, the search continues, driven by the twin engines of hope and curiosity. Each new advance in technology, each leap in sensitivity, opens fresh territory to explore. Perhaps somewhere in the hiss of hydrogen, in the rhythm of a pulsar, or in the faint regular beat of an unexpected frequency, there waits a message, a deliberate transmission, flung across the light years by beings as eager for contact as we are. The tools we build, the techniques we refine, are our invitation, our patient vigil at the threshold of the unknown. And so, under the wide star-strewn sky, the radio telescopes continue their silent vigil. Their dishes tilt and turn, following invisible trails across the heavens, collecting the stories that the universe tells in ripples of energy and time. In the great halls of data, computers sift through the noise, seeking patterns, anomalies, messages. The eavesdroppers persist, not knowing what they might find, but unwilling to stop listening. For in the act of listening, of tuning our machines and our minds to the subtle music of the cosmos, we become a part of that conversation, even if our role is only to listen. And as the night deepens, as the signals from distant stars accumulate in the memory banks of our machines, we are left with the sense that the story is not yet finished. There are still tools to build, signals to detect, and perhaps one day voices to answer. The cosmos is speaking, and we, attentive and hopeful, continue to press our ears to the vast starry dark, waiting for whatever comes next. There is a hush to the cosmos, a silence that stretches in all directions, deeper than any ocean, vaster than any field. We, on our small planet, have for more than a century been flinging signals outward, radio waves, television broadcasts, the pulsing heartbeat of our digital age, each a whisper of our presence, a beacon sent across the starlit gulf. And yet, as our electromagnetic echoes slip past Saturn's rings and beyond the pale blue halo of Neptune, the universe around us remains curiously reticent. No answering call, no return message, only the patient shimmer of distant stars and the soft static of cosmic background noise. It is in this grand stillness that we find ourselves poised, simultaneously exposed and alone. Our broadcasted existence is an unintentional confession. We are here, we are thinking, we are reaching out. Yet as decades slip by and our signals outrun the slowest spacecraft, the question grows heavier. Why is no one answering? Why, in a universe so ancient and so immense, does it seem as though we are the only voices raised in song? This is the Fermi paradox, the puzzle of the great silence. The physicist Enrico Fermi, pondering over lunch more than 70 years ago, gave voice to the unease that lingers even now. If there are so many worlds, so many chances for life, where is everybody? It is not a quiet doubt. It is a thunderous absence, echoing through the corridors of thought, unsettling the certainty with which we map our place in the universe. To grasp the weight of this paradox, one must first let the mind drift outward, past the boundaries of our daily lives, and contemplate the scale on which our signals travel. Imagine a faint ripple, an electromagnetic wave, born from an antenna's trembling breath in 1920s Pittsburgh. It radiates outward at the speed of light, indifferent to the limits of our own patience. In a single year, it will have traveled almost 10 trillion kilometers, brushing past Proxima Centauri's pale glow in just over 4 years. Each broadcast is a growing sphere, centered on Earth, expanding through the darkness, a slow and silent frontier. Within this expanding bubble, the stars number in the thousands, each a potential sun to hidden worlds. But as our signals travel, they grow weaker, stretched thin by distance, scattered by cosmic dust, diffused until the original message dissolves into the background hiss. Even so, for a brief window, perhaps 100 light-years, perhaps a little more, our presence is detectable. Beyond that, our voice dwindles to a murmur, part of the universal static. And yet, within that bubble, there are stars, old, steady, some with planets. Some of those planets may be cradling life, perhaps even intelligence. Statistically, it seems almost inevitable. The raw mathematics of the cosmos, hundreds of billions of stars in our galaxy alone, each with its retinue of planets, suggests that Earth cannot be unique. The Drake equation, that famous speculative formula, multiplies together probabilities, the rate of star formation, the fraction with planets, the number of habitable worlds, the likelihood of life, of intelligence, of technological civilizations and their lifespans. The result, depending on one's assumptions, could be many civilizations, scattered like rare pearls among the stars. Yet, in practice, there is only silence. The paradox persists. Some have proposed that we are not as loud as we imagine. Perhaps our signals are too faint, too short-lived, too easily lost in the cosmic noise. Perhaps alien civilizations, if they exist, deliberately shroud themselves in silence, fearful of the unknown. There is also the possibility that the window of detectable technology is brief, a mere flicker in the long story of a world. Civilizations may rise, broadcast, then fall silent, their signals fading before they ever meet another's ear. Others suggest the answer may lie in the very nature of life and intelligence. Perhaps the leap from simple chemistry to complex technological minds is so vanishingly rare that for all the stars we are the first, or the last, or the only. Or perhaps the universe is teeming with life, but most of it is microbial, content to flourish in oceans and soils, never dreaming of radio waves or spaceships. There are darker possibilities too. Perhaps civilizations inevitably destroy themselves through war, through environmental collapse, through the unintended consequences of their own ingenuity. The great filter, as some call it, may lie ahead of us or behind us in cosmic history. If it is behind us, then our survival to this point is an extraordinary stroke of luck. If it is ahead, then our future is fraught with peril. It is a lonely thought, and yet in that loneliness there is a peculiar kind of unity. For in the absence of cosmic company, we are forced to look inward, to recognize that, for now, we are all we have. Every person, every creature, every forest and river, every story told and song sung is part of the single, fragile tapestry of Earth. Still, our quest for connection persists. There are those among us who devote their lives to the search, tuning antennas to the whispering sky, sifting through torrents of data for the telltale pattern of an artificial signal. The search for extraterrestrial intelligence, SETI as it is known, has become a kind of scientific vigil, a patient listening that is as much an act of hope as of analysis. Each burst of static, each unexplained signal spike is scrutinized, catalogued, and invariably found wanting. A satellite, a cosmic ray, the mundane interference of our own machines. Yet the act of listening is itself profound. In listening, we admit the possibility of kinship. In sending our messages, be they intentional, like the Arecibo broadcast, or incidental, like the scattershot of our television and radio, we lay ourselves bare before the unknown. Our transmissions are not only technical phenomena, they are acts of trust, gestures of curiosity, declarations of existence. As the years pass, our technologies evolve. The early powerful radio broadcasts that once defined our leakage into space have grown weaker, replaced by fiber optics, by narrow beam transmissions, by digital encryption. Paradoxically, as our civilization grows more advanced, it grows quieter from the perspective of an outside observer. The Earth's radio glow is dimming, our electromagnetic voice fading into an almost monastic silence. If another civilization is listening, they may find only the faintest traces of our presence, a ghostly echo that hints at life but reveals little detail. and yet the very act of contemplating the possibility of others changes us. It is a mirror, reflecting our own hopes and fears, our longing for connection, our dread of solitude. The Fermi paradox is not merely a question about aliens, it is a question about ourselves. What does it mean to be alone? What does it mean to be part of a cosmos that is, for all practical purposes, indifferent to our existence? In pondering these questions, we begin to see the outlines of a deeper unity. For all our separateness, all our individual lives, we are united by our shared condition. We are the children of Earth, the only known bearers of consciousness and culture in an unfeeling universe. Our solitude is, in a sense, our gift. It binds us together, urging us to cherish what we have, to care for one another, to nurture the fragile world that gives us life. But the story does not end in isolation. The more we learn about the universe, the more we discover subtle threads of connection. The atoms in our bodies were forged in the hearts of ancient stars, scattered by supernovae, gathered into clouds and worlds. The laws that govern the spiral of galaxies also shape the dance of electrons in our cells. There is, beneath the apparent separation, a profound unity. We are the universe, knowing itself, struggling to comprehend its own vastness. Our broadcasted existence is, then, not merely a proclamation of our presence. It is a declaration of our longing, our refusal to be content with silence. It is an act of faith that somewhere, in some distant time or place, another mind may be listening, wondering, hoping, as we do. Even if that hope goes unanswered, it is a testament to the restless curiosity that defines us as a species. And so, the paradox remains. The silence of the cosmos is not a verdict, but an invitation, a mystery to be explored, a challenge to our imagination. Perhaps in time we will find that we are not alone, after all. Perhaps the universe is waiting for us to become worthy of contact, or perhaps the distances are simply too great, the odds too long, the barriers too high. In the meantime we listen, and we wait, and we dream. The night sky above us is unchanged, studded with the cold fires of distant suns. Yet, in the quiet of our waiting, something subtle stirs. We begin to see ourselves not as isolated beings, marooned on a tiny world, but as participants in a grand and ancient drama. The universe, in all its silence, becomes a canvas for our hopes, our fears, our longing for connection. Each step we take, each new telescope, each probe sent to the outer planets, each experiment in the lab, is a step toward greater understanding. We map the stars, we decode the messages buried in sunlight, we ponder the chemical signatures of distant exoplanets. We dream not only of finding others, but of understanding ourselves, our origins, our purpose, our place in the unfolding story of the cosmos. And perhaps in the end, it is this search that matters most. The journey toward knowledge, toward connection, is its own reward. In reaching outward, we discover the depths of our own unity, the bonds that tie us to one another and to the world that cradles us. The silence of the universe is not emptiness, but invitation, a vast and beckoning quiet, waiting for us to find our voice. Somewhere in the dark between the stars, our signals travel on. They are fragile things, easy to overlook, yet persistent, relentless, undeterred by indifference. Each carries within it a trace of who we are, our languages, our stories, our music, our laughter, and our longing. They are small, but they are enough, and even as we wait for an answer, we continue to speak, to send, to hope. The universe listens in its way, and we, in ours, continue to ask the question that has haunted us since the first humans gazed up at the night sky. Are we alone? But perhaps, as we listen and wait, we will come to see that our solitude is not a curse, but a calling. It is an invitation to cherish our world, to understand our own nature, to build a civilization worthy of the stars. And as the silence stretches on, as our signals fade into the darkness, we may find in the quiet a unity deeper than any answer, a sense of belonging, not just to Earth, but to the universe itself. So let us listen and let us wait. Let us dream of distant voices, even as we cherish the ones we already know. For in the hush of the cosmos there is room for wonder, for hope, for the slow unfolding of understanding, a journey without end, a story still being written, as the stars wheel overhead and the night deepens around us. As our journey through the quiet cosmos of old TV shows and wandering aliens gently drifts to a close, imagine their signals like a comet tail fading into the hush of space, softly reaching out across the stars. Rest now in the wonder of these distant echoes, and when your dreams seek new mysteries, return with me for more whispered tales beneath the velvet night.